All right, let's start. So today our outline is very simple. We only have some announcements and a big recap session. So for announcement 1 is for assignment 1. So most of the specific questions are released except for question 10. We are still working on it because Dylan is creating some corresponding testing scripts for all the questions. We need to make sure that the questions will work properly under array corner cases. So, and the submission deadline is before week 6, Friday of week 6, and don't forget to get the free styling mark. So the second announcement is is related to quiz 3 question 1. So today some students were asking about the correctness of option E. So why E is not correct? Actually, there's a special case where the value of x, the name of x could be null. So let's see an example here. Actually, this is how you can do these programming quizzes. You can just run the SQL statements on somewhere and test out the results. So the question gives us two tables. So X has a name which is unique, but it doesn't say name is not null. Remember, null is a special value. It could match to most of the cases. It belongs to any domain. So X, the name of X is allowed to be of null values. So this is the key thing here. And for Y is just another table which has a reference to X ID. And since the name of X is not specified as not null, we can insert null values into X. And in this case, we have inserted two X entries with null value as the name, and we populate the table for Y. So let's run this E and B and see their differences. So as you can see, X E is wrong because it's not dealing with the null value correctly. So only one is counted here. Only one is counted here. However, it should be 2 because we have inserted 2x with null values. So the error here is because it's selecting distinct x value, and although x is specified as unique, it could take the value of null, and two null values are equal to each other. So that's why this one will give us no matter how many x values have the null as its name, it will only give us 1. So that's why E is not correct. E is not correct. And I don't know why, because some of you were answering this. This one was a question posted by one of the students, and another student answered by saying that in the previous term the quiz there was something, and I don't know why you have access to the to WebCMS of previous terms. You shouldn't have access to that, and that's about question Assignment 1, assignment announcement 2, okay. That's our oh, sorry, just clicked. That's announcement 2. So the results of the marks are your answers are marked according to the correct answer. So only B is the correct option for question 1. So E is not correct. So the mark has no problem. And for help sessions, last time one of you pointed out that there's an overlapping on Thursday with our lecture, and I have informed the teaching support team to rearrange this help session, and let's see how it responds. And our last announcement today is that there's no quiz this week, so you can focus on your assignment 1. And now let's have a recap of all we have learned since the start of this course. And here are some interesting statistics. So for quiz 1 and quiz 2, the average mark is about, since some of you may have known that we are inheriting all the quizzes from previous terms. So quiz 1 and quiz 2, the average mark is about 3 to 4% better than previous term. And quiz 3 average mark is about 10% better, and that's very good. And the bad thing is the average mark is dropping quiz by quiz. So I hope you could stop this trend. Although it sounds like the course content is getting harder and harder, but just now, like what I've shown you with the question 1 of quiz 3, you can just try out on your own laptop. You can just execute the programs. So it shouldn't be harder than quiz 1 and 2. So I hope you could stop this dropping trend. And there are always about 10% of the students who never do any quiz in every term. And I don't know why, because we are trying our best to get all the students notified, and but still like 10% of the students never do any quiz. And for this course, for marking, we don't use things like bell curves. So each one of your mark is not affected by your peers. So help each other. And I already saw that some of you are actively answering questions on the forum for other students, and this is very nice. And here are some statistics. So we have some top askers, and we have some, and Dylan is very helpful. He's answering a lot of questions, and we have some students answering questions for others as well. And yeah, I'm viewing the forum almost every day, and some students, you even received some hearts for answering questions for others. But I think some of the students here, they receive hearts because they post some memes on the forum. And when talking about asking questions, so you can ask almost any question as far as is related to this course. So you may ask, why don't we learn cross-foot notation? So you can also ask about the mic problem or the sound effect for the recording. I don't know if this one, because I'm using the handheld mic today. I don't know if it will sound better in the recording or not, but let's see. So you can ask any question, and you can ask why we learn some content, why we learn certain topic, right, in 2024. So why are we still learning these some old knowledge? You can ask almost any question. And yeah, that's very good, because it's good to not take things as granted. So this is very, very important. And I hope that you could think independently and work collaboratively. but not for this assignment, because this assignment is individual assignment, so don't try to work it out on your own. And let's have a quick, now we can have a quick recap of what we have learned since week 1. So in week 1, the first topic we have covered is data modeling. And do you still remember the concept of data modeling? So data modeling is actually a design process. So it doesn't have an absolute correct or absolute wrong answer. So that's data modeling. And the aim of data modeling is to describe the information, the relation between different pieces of information and the constraints applied to this information. And the input of data modeling process is just the specifications, normally from the end users or customers. And the output is like a formal modeling of the whole database system. And we covered ER modeling, which is one of the data modeling approach. So ER stands for entity relation. And do you still remember the concepts here, the key concepts here? So other than entities, what else do we have? What else keywords? Yeah, of course, relationships, because R stands for relationships. And what else? Yeah, that's related to relations. And another key concept here, what's related to entities? What is related to entity? Attributes, yes, great. Attributes. So here are some key concepts. And now let's go through the symbols to see if you could still remember the meaning of these symbols. So what's the first one on the top left corner? So what's this? What does this symbol stand for? Entity, yes, entity. I saw many of you saying that. So what's the second one? Starting from the second one on the top left. Yeah, the relationship. The diamond shape is a relationship. And the third one. Yeah, attribute. And fourth one. Yeah, inheritance. Great. And the next one, the fifth one. Not exactly. It's not an attribute. You see, it's a rectangle, so yeah, it's not called secondary. It's weak entity. Weak entity, because you see, it's a rectangle, so it is an entity. It's not an attribute. So what about this double-lined diamond? Yeah, weak relationship. And what about this one? Yeah, it's not weak attribute actually. Multi-valued. Yes, this is multi-valued. And what about the last one? We covered this in, but we seldom use it. It's called derived attribute. It's like this attribute could be calculated based on other attributes. For example, age could be calculated based on birth date. So if birth date is one of the attributes, age could be a derived attribute. So this is the meaning of these symbols. So talking about attributes, another key concept here is key. So key, we know that key is made up of attributes, but what is the definition of key? Of a key here, or key is equal to super key here, the notion. So what's the definition of key? So key is actually a set of attributes that could be used to uniquely identify an entity. So it's like a unique identifier. But what about candidate key? So what's the difference between key and candidate key? The definition here. What's the difference here? So since key is a set of attributes, it may not be the minimal set required to uniquely identify an entity. So we can, in an extreme case, we can use all the attributes of an entity as a key. So candidate key here means the minimal set of attributes that is required to identify an entity. So that's the definition of candidate key here. So what about primary key? Primary key is the candidate key selected by the DB designer to use as the unique identifier. So that's the definition here. So talking about relationship, here are some keywords. So level, what is the definition of a level for a relationship? Do you still remember that? Yes. How many different types of entities related to that relationship? And what about cardinality? So what's the meaning of cardinality here? Yes. It's to describe how many entities. So the level is how many different types of entities, and cardinality is how many entities on each side of the relationship. And what about participation? So the participation means whether every instance of an entity should get involved in a relationship. So this is participation. So this is a part of the ER diagram of assignment 1. So let's try to describe from left to right the releases and movies. Let's try to describe this relationship here. So can you describe it? Almost correct, but you may need to change the term to describe the relationship here. So we can say that every release must be related to one movie, must have one movie. And if we describe from right to left, we can say that a movie may be published as many releases. So it allows some movies to have no release. So this is the relationship here. And the last concept for ER modeling is inheritance. So talking about inheritance, what's the difference between disjoint and overlapping? So what's the difference here? Disjoint means each subclass, they shouldn't have overlap. So if an entity belongs to one subclass, it is not allowed to be belonging to another one. And what about participation here for inheritance? It's very similar to the participation in relationship. It means for total participation, it means every instance of the superclass should be belonging to at least one subclass. So this is the concept of participation in inheritance. And talking about the notation of ER diagram, one of you asked at forum, why not? There are many other notations for ER diagrams. So why we use this special type of notation? Why not use some others? For example, cross-foot or Chen's notation. So why not? As you can see, this is cross-foot notation because the symbols here looks like the foot of a crow. So that's why it is called cross-foot notation. And it can express almost the same thing as the notation we are using here. So it is also used to describe cardinality, as you can see, but it has more detailed description. As you can see, it differentiates between 1 and 0 and many. So in our notation, we don't differentiate 0 and 1, 0 or many. And the reason is that 0 is a very, very special case. As we have seen in quiz 3.1, question 1, so now is a special value. Actually, 0 is also a special value because 0 means cardinality is related to cardinality. So it's related to the quantity, so it's related to cardinality. However, it is also related to participation because 0 means we allowing an entity to not participate in this relationship. So 0 also indicates not total participation, partial participation. So this is why 0 is special. And cross-foot, you can see that the notation for 0 and for denoting 0 and cardinality and participation is related actually. So that's why it is also faced with the problem of dealing with cardinalities and participation. So the expressiveness of cross-foot notation and our notation is almost the same. So the notation used in this course doesn't actually have a name, and it is a legacy problem because the course materials heavily rely on the textbook called Database Systems, the complete book. So in that book, the notations are like this, so we followed that. And this is why we are not using other notations. So if you want to know more about different types of notations, you can refer to this additional slides. So in week 1, we have also learned about relational model. So do you still remember the concept of relational model? So the concept of relational model is to use relations to describe everything. So relations could be considered as tables. And what about the concept of schema of a relation? Do you still remember that? What's inside the schema of a relation? The name of the relation and a list of attribute names and domains of attributes. So that's the schema of a relation. So what is the definition of a tuple here? A tuple is a list of attributes. So since it is a list, it's not a set. Order matters here. What about relation instance? What about the concept of relation instance? it is defined as a set of tuples. And since it is a set, ordering doesn't matter here. So that's the concepts. And there are 4 types of constraints used for relational model. Do you still remember that? This is quite hard to remember actually. So the first one is called domain constraints. So do you still remember the concept of domain constraints? So like what we have discussed for the schema of a relation, it is a relation name followed by a list of attribute names and their domains. So each attribute should be belonging to a certain domain, and that domain could have a range. So this is the domain constraint. And there are some other key constraints. What is called a key constraint? Yes, unique and not null actually. Keys should be unique and not null. So what about entity integrity constraints? So it means entities must have keys. So that's the short version to describe entity integrity constraint. What about referential integrity constraint? Referential integrity constraint means that some attributes are referring to the actual value of attributes in other relations. So this referential relation should be maintained. So this is called referential integrity. Please keep quiet in the lecture. And that's all about relational models. And in week 2, we covered some more topics. So the first one is relational modeling and ER modeling mapping. So what's the difference between relational models and ER models? So there are actually 3 types of differences. So relation models use relations to model both entities and relationships in ER models. So it's like using tables to model everything. And relation models don't have composite or multi-valued attributes. And the third one is relational models, they don't have object-oriented notions, for example, subclasses or inheritance. And these 3 differences will cause us troubles for mapping. So when we think about how we map between ER models and relational models, we should think about the differences here. So let's just follow the order here and look into the mapping case by case. So first, since relational model uses relation to model both entities and relationships, let's think about how does relational models model ER entities. So for example, for this entity, what is the corresponding relational model? So what is the header of the table we should have? is very straightforward, right? It's just a student and followed by some attributes as column names. So what about weak entities? No, we should have a separate table for each entity. And for weak entities, we just have a separate table for this entity, weak entity here, and use the primary key of the associated strong entity as the foreign key here. So this is how we map weak entities. And now let's look into how we map relationships. So the first one is many-to-many relationship. So how many tables should we have here? Yes, 3. So for matching many-to-many relationship is very straightforward. We just have 2 tables for each one of the entity here, and we have another table for the relationship. And what should be inside the table of the relationship? Yes, we should have the 2 primary keys from the associated entities. So this is what we have in the end. What about one-to-many relationships? How many tables should we have in this case? 2, yes, correct. So why 2? Where should we put the relationship? Because this relationship, you see, there's an attribute associated with this relationship. So where should this attribute go? Which table should this attribute goes into? Yes, on the side of the many entity, because the number of instances of the relationship depends on the number of the many side. So that's why this attribute should be belonging to the many side, as you can see in this example. And also we should have a foreign key connecting these 2 tables together. And the last relationship here is one-to-one relation. So how many tables should we have in this case? 2, yes, 2. I heard someone saying 2. So actually, it's kind of similar to one-to-many relationship, and the only the difference here is that it's very similar actually. We just keep the reference of one entity as a foreign key in the other entity's table. So this is how we map one-to-one relationships. However, there's a special case. So in this case, only on the manager side, there's a total participation. So every manager, it means that every manager must be belonging to a branch. So that's why we can put the branch number attribute inside the table of manager. What if both sides are total participation? So what if we have thick lines on both sides? What should we do here? So this is actually related to some forum questions asked by actually one of the students here and 2 other students. And so what if both sides are total participation? So can we, this is, you can refer to these threads. So can we just put a foreign key of employee number in the branch table? So can we do the same thing as how we ensure the total participation of manager? Can we do this? From the modeling point of view, we can do that. We can put it there. But from the implementation point of view, if we really want to implement this into SQL, this will give us a problem. The answer is no here. But do you know why? Why is no, we can't do this? Some of you have tried that out and it ends up in errors. But why it will give us an error here when we actually implement the SQL table? It's not about uniqueness. Yes, actually, what you mentioned is the correct answer. So the term here to describe this situation is called circular dependency. So if we put employee number as a foreign key in the table of branch, and we put the branch number as a foreign key in the table of manager, we will have circular dependencies. So when we create the table of manager first, let's think about it. If we create the table of manager first, and we tell SQL that a branch number should be a foreign key referring to the branch number in the branch table, but since we haven't created the branch table yet, how can we do this? Let's say if we do the same thing the other way around, let's try to create the branch table first, and then we will run into the problem of not having the manager table created. So this is the circular dependency here. So that's why in actual implementation we can't simply put a foreign key of employee number inside the table of branch. So as you can see, circular dependency is a tricky case, but how do we deal with this type of dependency? So the first solution is that we can create both tables without foreign keys first. So we create the tables, as you can see, we are holding the foreign key as an attribute here. We are declaring this attribute, but we don't tell the database that it should be a foreign key. So we don't specify the foreign key first. We just define the attributes. And then, because we are not inserting into the data into the table, we are not having any trouble here. And after that, we can add foreign key constraints after table creation using the alter table statement. So remember, we can modify the table, the metadata of the table. So we can add more constraints into existing tables. So in this case, since we have already created both tables without specifying the foreign keys, we can safely alter the table to tell that there are certain constraints for the foreign keys, and the database won't complain about it because the tables are there. And after that, we can insert data with circular dependencies. So the way we insert the data is we can insert into A without BID first. And then we insert into B with AID. And then we update table A with the newly created ID of B. So this is how we add new data inside the two tables with circular dependencies. And what I suggest is that we need to make the entire thing a function, and we should also make it a trigger. And we will learn about trigger, the concept of trigger later. So it is automatically, it is like some procedures or functions which are automatically triggered when certain actions are performed. So this is the first solution for dealing with circular dependencies. And the second solution here is unique for Postgres actually. We can have deferred constraints. So the constraints by default is checked after when running that statement. So it's on statement level. So constraints are checked per statement. However, we can defer certain constraints to be checked after the entire transaction of several statements. So this is actually unique to Postgres. So the deferred constraints are checked only after we have finished the entire transaction, the entire block of statements. So this is helpful. So what we can do is we can declare the foreign key constraints as deferrable, initially deferred. So in this case, these constraints won't be checked until we have finished the execution of the entire transaction, and it won't complain about, and SQL won't complain about this case. So with the deferred constraints, you can insert rows into both tables within the same transaction, and the database won't complain. So this is how we deal with circular dependency with Postgres. And of course, there's a third solution here, which is just to change everything from the designing level. So you can design your database to avoid circular dependencies. So that's the ultimate solution, of course. But sometimes you can't avoid circular dependencies, and you will need to use these two solutions. So we have covered all about how we map entities and different types of relations. So what about attributes? The second difference. So relational model doesn't have composite or multi-valued attributes. So for example, for this composite attribute, how do we map it into a table? How do we map this one into a table? Not really. We don't need to create another table. Yes. We can just collect array attribute and put them in the customer table. And in this case, we are losing some information, the information is about relating state, city, state, zip code to address. So we are losing the information of address, but we are keeping array attribute here. So this is how we deal with composite attributes. So what about multi-valued attributes? So in this case, assume we have a person. A person could have multiple favorite colors. So how should we create the table to describe this here? Yes, that's correct. So we can create another table called favorite color and link it to the person table with the primary key of the person as a foreign key here. So this is how we do this, and this is essentially changing the multi-valued attribute into a weak entity. So this is how we deal with different types of attributes. And the last difference is about mapping object-oriented notions. So there are 3 styles for mapping superclasses and subclasses. So what are the 3 styles here? So do you still remember the names and the definitions? So let me give you a hint. The first one is called ER style. So what is ER style? Yes, very close to the correct answer. So for ER style, we create a separate table for each subclass, and we don't put out, each subclass should have their own attributes, and they are related to the superclass using foreign keys. So that's the ER style. And the second style is called OO style, object-oriented style. So what's this? So for OO style, every attribute, every subclass is also mapped into a unique table. However, in this time, every table is the table of a subclass is holding all the attributes from the superclass. The difference between this O style and ER style is that in ER style, the table of the subclass doesn't have the attributes of the superclass. So that's the key difference here. And what about the last style? Do you still remember that? The last style. The last style is we collect all the attributes from all the super and subclasses and put them into one table, into one single table, and allow the value of certain attributes to be null, because some subclasses, they don't have certain attributes, so we allow those attributes to be null for those subclasses. So that's the third style. So these are the 3 styles we have covered. And that's all about everything before we touch SQL, and let's have a 10 minutes break. You can grab some snacks here. All right, let's start the second half of today's lecture. Please keep quiet. Please keep quiet. And the second half is about SQL, what we have learned till now. So do you still remember the basic syntax of SQL? So before you think about the syntax of SQL, do you still remember the full name for SQL? So what does SQL stands for? Do you know the full name? Yes, yes. Structured query language. So S stands for structured. So the basic syntax. So what's the symbol used for comment? Yes, double dash or double minus sign. And what about the keywords in SQL? Should we just use capitalized letters, or can we use small lowercase letters? Actually, it's like we can use anything for keywords, but we'd better use uppercase. It's just a convention, but it's not a restriction. So, and there are many different data types and operators and different types of constants, and let's go through them one by one. So for data types, there are different types of numeric data, and we have integers, we have float, which is very similar to other programming languages. And for chars and strings, it's a bit special here because it's a database. It's eventually storing the data somewhere in the hard disk. So the types of strings are related to the size of space to be stored on the disk. So for strings, for example, we have char followed by a parenthesis specifying the maximum number of characters that could be held by this attribute. And what about varchar? So what's the difference between char and varchar? It's not how you define how you specify what is the difference from the semantic level or the actual implementation level. So what's the difference? The difference between varchar and char is that the varchar is stored as variable length on the disk. So it has a limit. Let's say we have varchar parentheses 10. Then the maximum number of characters could be stored in this attribute is 10 characters. However, if we store one character into this field, only 1 byte is consumed on the disk. If we define the string as a char 10, then 10 bytes will always be used, no matter how much of no matter the length of the actual string. So that's the difference between char and varchar. So is there a type that give us unlimited length of string? So is there a type for us to do so? Text, yes, text. So text is a data type that allows us to store string of any length. And the next data type is time and date. It's very, very similar to time and dates in other programming languages, for example, Python. However, there's a key type here which is called interval. If we use timestamps to if we minus one timestamp from another one, we will get a time interval. It is used to describe a period of time. So that's the data type you should take note of. And what about type conversion? So what is the syntax for doing type conversion in SQL? We use a double colon to represent type conversion. We will see that later in an example. And SQL does allow user-defined data types. So what is the syntax for defining defining a new data type, a customized data type? Is very similar to tables. Is create. So we can create domains, we can create types. And what's the difference between domain and type? Creating a new domain and creating a new type. Actually, this is a very detailed question. So a domain is based on a basic type from SQL. So we can create a domain based on integer. We can create a domain based on float and specify the range of that integer or float. So if we create a domain, we must associate that domain with an existing type. So that's domain. And for type, we don't have such a restriction. We can create a totally new type. So that's about data types. And we also learned about some basic operators. So there are many different types of comparison operators. So do you still remember the symbol for inequality, for checking not equal? So what's the symbol for not equal? Yes. It's like smaller than followed by larger than. And for Boolean values, so there are many Boolean operators. Like other programming languages, we have and or as the operators for calculating Boolean values. So, but remember, now value is a special case here. Do you still remember what is the value of, let's say, true or null? What is the result for true or null? True. Yes. What about false or null? Yes, null. What about false and null? False, yes. And what about false or null? Null. Actually, the value is null. So the key for remembering this, there's a large table for mapping between different input values and different operand values and the result of the Boolean operators. So the key for remembering that is true or something is always true, and or false and something is always false. And if the other side is null, sometimes it could be null. So that's how you remember this calculation process. And there are also some operators for string matching. So there are built-in mapping wildcard strings for mapping any string with SQL, and the keyword is like. And we could also use regular expressions for matching strings. And for the special value null, do you still remember how do we check if a value is null or not? Can we use the equal and not equal sign? Can we use that? No. But what should we use? Yes, yes. We should use is now or is not now. And now value is very special because for quiz 3, question 1, you remember that now value is important. So talking about data types, let's go into a forum question. So it is a recently asked one. So one of the students asked how to convert any integer into a formatted string. Like in Python, there's a standard library in Python for doing this. But how do we do this in Postgres? Of course, we can use some. We can do it with some arithmetic operations. We can calculate the values and store and try to build the format string. We can do that, but is there any other way of doing so? Actually, there is. So we can use the toChar function, which is a built-in function, to convert things into strings. And remember, this is how we do the type conversion. We can convert this formatted string into a time interval, and then we format this time interval into a formatted string. So this is a way of doing integer to time conversion in Postgres. And after that, we have also learned data modification in SQL. And the first one is about insertion. So do you still remember the syntax for insertion, for insert? Yes. Insert into a table followed by a list of assignment. And there are different styles of inserting into a table. So let's think about it. We can specify only the table name. We can just tell insert into a table and followed by the assignments. And we can also specify the attributes to be inserted, because some of the attributes are not required to be are optional. They are not required to be not now. So we can insert into a list of attributes of that table. And we can specify that in this insertion statement. And that's the second style. So we can also insert multiple values with one statement. However, that is not enough in some real-world cases, because sometimes we want to insert really a big amount of data, maybe from other programs, maybe from a file. And in that case, what we should do is we should use the bulk insertion function provided by the database system. And in Postgres, do you still remember the keyword or the command to use here? What is the command to use? This is the command to use here for bulk insertion is called copy. And we can insert from the output of another program, from a file or standard in. So that's how we do bulk insertion. And the second data modification statement is deletion. So do you still remember the syntax for deletion? Is delete from. So let's think about, because we can delete from some table where a certain condition is fulfilled are matched. And if we don't specify the where clause, so what's the default behavior here? Nowhere equals to what? What? Yeah. If we don't specify the where clause, the condition of where, it means we are true. So everything is matched. So that's the default behavior. And since we can use some conditions to delete certain rows, so how is this filtering and deleting done in SQL? There are two ways of doing it. We can go through the rows one by one, check the condition. If the condition is fulfilled, we will delete that row during this loop. Or what we can do is we can try to go through the rows one by one in the first loop and take note of the rows that could fulfill the conditions. And then we use another loop to go through the rows, and with the note we have taken off, we delete the rows. So what's the difference here? So what does Postgres? Postgres is using the first type of, the first implementation to do deletion, or the second one? The second one, yes. We have shown it with an example. Postgres will take note of the rows that could fulfill the conditions first, and then do the deletion. And this type of implementation will delete more data than the first type of implementation in some cases. And you can find that an example in our previous lecture notes. And there's another way of deleting things from a table, which is called truncate. And what's the difference here? Actually, this is a question asked by one of the students on the forum. And let's try to look into the difference through an example here. So this is the example we have used for our previous lecture. We have two tables here. The first table is called employee. And every employee has a ZID, name, role, and intro. And the second table here is called contact. So contact is like a weak entity of employee. So it has a foreign key holding the ZID of an employee as a primary as a foreign key here. So this is, so if let's say if we just insert into the employee table and we don't insert into the contact table, so how could we delete everything from the employee table? So what we can do is we can just delete from employee without specifying the where clause. So it means everything is matched and everything will be deleted. So let's run this. As you can see, nothing is left. So this is as expected, the behavior of this command. However, if what we can do is we can also use truncate. We can truncate a table to delete everything inside that table. However, if we don't specify the cascade keyword here, what will happen is Postgres will complain that contact table is referencing the table we are trying to truncate. So we can't safely delete employees, because if we delete an employee, we are violating the referential integrity, because this if we delete an employee without deleting the related contact, that contact will have no associated employee. So that's why we can't do this. What we can do is we can delete, we can truncate cascade. And this time we can clear up the contact table, the employee table. However, let's do a small variation here. Let's try to insert a contact into the contact table, and this contact is referencing one of the employees. So what will happen this time? So if we truncate cascade, it will still we are still safe. And if we look at the contact table, we can see that the contact is also removed. So this is how cascade works. So it's removing all the related data items. So this is truncate. However, just now we were doing deletion, and it doesn't complain. It will safely delete everything from the employee table. But what about this time? So will it still work? Let's see. So as you can see, an error occurs because we are trying to delete an employee that has some contacts, and we can't safely remove that employee if we don't remove the associated contact. And to deal with this case, what we can do is when we define the table when we define the foreign key here, we can specify the on action here. We can say on delete cascade when we define the foreign key here. It means that if the associated strong entity or the associated entity is deleted, this one will also get deleted. And if we add this thing here, as you can see, it works out, and the contact is also removed when we delete from the employee table. So this is the key thing here. So the difference between delete and truncate, as you can see, is that truncate will check no matter the data is as far as the table is used by some other table. So as far as, because it's table level operation, truncate is table level operation. As far as this table, one of the attributes of this table appears in another table as a foreign key. As far as this thing happens, it doesn't care about the data. So even if there's no actual data in the table, it will fail. That's truncate. And delete is tuple level. So it will only report us an error when a tuple violates the referential integrity. So if we have nothing inside the contact table here, so delete won't complain, even if we don't specify the cascade deletion behavior. So that's the difference here. So this is a question from forum. And after the insertion and deletion, we also have update. So do you still remember the syntax for update? So we have, yes, update followed by table name set and followed by a list of assignments and where conditions to filter out the data. And do remember that during updates, we could use some calculations during the assignment. So for example, we can use update to reduce certain numeric values by half. So during the update, so that's how we do update. And after that, we learn how do we retrieve data from database, and it's using some queries. And remember that SQL queries are declarative. So the meaning of declarative here is that we should we only describe what kind of data we want, but we don't tell SQL how to get that data. So all the queries are used just for describing the data we want. So this is why it's called declarative. And do you still remember the keywords for doing queries? The most important word for doing queries. Select. Actually, it's select. You select from a table. Select certain values from a table and followed by where and followed by some other keywords. So for query results, we have some operators to operate on those query results. And do you still remember whether a query result is a set or a bag? So what's the difference between sets and bags? The concept. Yes, yes. Sets, the value, the elements in sets are unique, and bags allow duplicates. So that's the difference here. And all the query results by default are bags. So what if we want them to what if we want a set? Yes, we can use the keyword distinct. And there are three different set operators: union, intersect, and except. For union and intercept, the order of the operands doesn't matter. So we can put A union B equals to B union A. However, A except B is different from B except A. So do you still remember the difference here? And another keyword we learned is called exist. So what does exist do? Yes, yes. It tracks whether a given set or bag is empty or not. So that's exist. And what about in? In is used to check whether an element belongs to a set or bag or not. And these set operators, by default, they will generate sets for as the result of the calculation. So what if we want them to generate bags? What's the keyword to use here? Let's say for A union B, it will give us a set. So what if we want a bag here, A union B? We should use the keyword all, the A union all B. So that's how we convert between sides and backs, and the default behavior of them. And we also learned some aggregation operators which will work on columns of data. So the most common ones are numeric aggregation operators. For example, we can calculate mean, max, we can calculate average. And a special case here is count. It could be applied to non-numeric data. And another concept here we learned about queries is about grouping. So do you still remember the syntax for using groups? The keyword here is group by or partition by, and group by is used on the statement level, and partition by is used on value level. And what if we want to filter groups when we use group by? What's the keyword here? Having. So after group by certain values and having something, we use having to specify the condition to filter out certain groups. And what about the restrictions of using group by? Yes, if a value is not used for grouping, it should be used in the it should participate in an aggregation operation. So that's the key here. And what's the difference between group by and partition by? Group by is to generate groups is to summarize data according to the groups. So it's to group all the rows according to certain attributes and then provide a summary for each group. So this is group by. And for partition by, it is used to augment every row with some group-based values. For example, in our example, we have shown that we used a table of cities and temperatures. So we can augment every row of data with the average temperature of that city, partitioned by that city, as to augment that row. So I don't know if you can still remember that example. If you can't, you can look into the relevant slides. So that is group by versus partition by. And all these queries are related to, can be used for single table queries. However, in reality, we need multi-table queries. So do you remember the keyword here for doing multi-table queries? What's the keyword here? Yes, join. We can use join to join multiple tables together. And there are different types of joins. So do you still remember some of them? Yes. Actually, the first two types are inner join and outer join. And for outer join, we have three different types. We have full outer join, we have left outer join, we have right outer join, but we can omit the outer keyword here. So in the end, we have inner join, which is just join. We have left join, we have right join, we have full join. So that's all the different types of joins we have. And what are the differences between the results of these joins? Actually, this could be illustrated with some examples here. This is the example I used in the lecture slides, but there are some better illustrations I will show you later. And another key thing to take note of is sometimes we may need to join a table with itself. So in this case, what should we do to make sure that SQL won't complain? We should give each instance of that table a unique name. So if one table appears twice or more times in one statement, we should give each instance of that table a unique name. So this is something we should take note of. And talking about the illustration of drawings, one of the students proposed has found some website that has a very nice illustration for visualization for showing different types of drawings, and this is an example. So these two tables are linked together with a foreign key called user ID. So this user ID of table 2 refers to the ID of table 1. And as we can see, only one ID 1 is matched on both sides. So if we do an auto join, so everything will be included, and this is what will happen. And the default value for the absence of certain attributes in the joined row is null. So the white colored cells are having the value of null. This is what will happen for outer join. This is what will happen for inner join, since ID 1 is the only one that appears in both tables. So this is the result of inner join. And for left join is to include everything on the left table and the matched results of the right table. So that's left join. And for right join is the reverse. And in this web page, actually there are two other types of joins which we haven't covered in our lecture. The union join and cross join, but they are useful but not commonly used, and you can check them yourself if you are interested. And so that's all about the multi-table queries. And sometimes we can store query results into views. So do you still remember the syntax for dealing with views? So we can create view followed by view name as a query. And if we want to drop a view, we can just use the keyword drop. And views are temporarily stored in the database, and they are references to the original data. So dropping views won't affect the original table. However, if we modify through views, if we update the data through the view, then the data in the original table is also updated. And if we update the original table, the data collected from the view will also be updated. So that's the behavior here. So it's just like a pointer in C programming. So that's the key mechanism of views. And sometimes we have materialized view. And materialized view is to actually store the view on the disk. So the mechanism difference is that materialized view are used as real tables by the DBMS, And and normal views are when they are used, the DBMS will just convert the queries to a view into queries to the original table. So that's why the temporary views or the normal views are slower to use than materialized view. So if you query from a materialized view, it's much faster. So that's the difference between materialized view and a normal view. And after we learned about the queries, sometimes the queries could be very, very complex, and we need some means for abstracting these queries. And there are three different ways of doing so. So the first one is we could use a view to store some intermediate results, and the second one is to use from. We can deal with from a subquery, and the third one is we can use the with keyword. So with a subquery, and then we followed by some other statements. So these are the syntax differences between these different styles. And one special thing about the with clause is that it is useful for doing recursive queries. So do you still remember the usage scenario for recursive queries? Do you remember the example we used to demonstrate recursive query? Recursive query is used to traverse multi-layered data. For example, in the example we used in our previous lecture, the data is called part. It's a part of a computer, and the part could have a subpart, and the subpart could have a subpart. And how, given a root part, how can we grab every subpart, including all the subparts? So we could use recursive queries. So that's the usage scenarios of recursive queries. And the key components of recursive queries are: we need an initial state. We need a query to initialize the table we should operate on. And then we use another query to update this table, this initial table. And the second query should involve the temporary table or the temporary result we declared using the with clause. So recursive query is very, very similar to how you write a recursive function. So this is how recursive works. And lastly, we learned about SQL functions and PLPG SQL functions. So for SQL functions, do you still remember the syntax? It's create function followed by function prototype, followed by return type, followed by the function body as a string, followed by the language of that function. And for return type, we could, since sometimes the functions could return some tuples with selected attributes. So for how do we deal with that? We could either use a custom defined type, or we can temporarily use a table followed by a list of attributes as the return type there. And since SQL functions, they can only hold SQL statements. So what's the difference between SQL function and views? The key difference here is that SQL functions could have parameters. Sometimes we need to encapsulate certain operations, which takes some parameters. So that's the key difference between SQL functions and views. And how do we invoke SQL functions? What's the keyword here for invoking SQL functions? Select. You must be very familiar with this for doing your assignment 1, and the keyword here is select. And what about accessing parameters inside the SQL function? There are two ways of doing so. Yes, the first way is to use parameter name. The second way is to use $ followed by a number, and the number is the order of that parameter in the function prototype. So that's SQL functions. And we also learned about some stored procedure. So do you still remember the syntax here? So it's actually very similar to SQL functions. The only thing, the difference here is that we don't specify the return value. And what if we really want to return something? We should use the keyword returning inside the body of the procedure. So stored procedure is just a collection of SQL statements. So what's the difference between stored functions and stored procedures? So the design purpose of these two concepts are different. Stored functions are expected to return something, and stored procedures are not expected to return things. So that's why in the default syntax, SQL functions should specify return type, and SQL and stored procedure don't need to do that. And what about the keyword for invoking stored procedures? What is the keyword here? Call, yes. The keyword is call, is different from SQL functions. And for PLPG SQL functions, so the full name is called procedural language extended PGSQL. So what's the difference what's the syntactic difference from SQL functions? So the declaration of the function prototype is exactly the same. However, the function body is different. We could declare variables at the start of the function body. And there are some other key concepts here, which we may not have enough time to cover, but I will cover the most important concepts here. So the key thing here about PLPG SQL is that it has control flow elements. It allows the functions to have branches and loops. So you must be very familiar with how to create an if-else branch, how to create loops. And since you are doing your assignment 1, you may encounter a lot of bugs with your created functions. How do you do debugging in this case? How should you do debugging? You can use the keyword raise notice to print out some intermediate calculation results to help you with the debugging here. And of course, like many other languages, PLPG SQL does support exceptions handlings. So that's the key concept here. And the last thing is PLPG SQL does allow us to dynamically generate queries. We can generate a string and execute that string as an SQL query. So what is the keyword for doing this dynamic execution of generated queries? What's the keyword here? The keyword is just execute. We can execute followed. We can use execute followed by a string of SQL statement and execute that statement as as an SQL query. And it's very similar to the concept of reflection in Java or Python. So the Python function to do this reflection is called eval, E-V-A-L. So if you are familiar with Python, you will be familiar with the execute concept here for SQL. And that's all about what we have covered for the first half of our course. And that should be enough for you to do your assignment 1. And please try to do your assignment 1, work on it. And I'm trying to avoid the case that we are teaching you 1 + 1 = 2 in the class and ask you to do some calculus in assignments. We are avoiding that, but sometimes you may have to search for Google for some corner cases if you encounter certain questions in the assignment. So that's all about today's lecture. And in our next lecture, we will learn more about SQL triggers and other advanced features. So that's all. Thank you.
Might sound stupid, but I was trying to open my file, but it said can't open it in VS Code. Please try another server.
Can't open that in
VS Code. Basically, I accessed SSH. Through SSH, I cloned the file and everything. Like I copied the command I was given in the assignment spec, and I got the ass1.sql file when I look at the directory. But when I try to open it, it says that it can't be opened in VS Code. Please use another server.
Can try to post one question on the forum, or maybe you can.
Somebody else actually posted it on the forum, and Dylan replied